I'm going to show you how to use Sketch Picture to help you capture the geometry of the heating element. And so to do that, what we would do is start with an open sketch. And I'm going to bring my picture in on the top plane. You can bring it in on any plane that makes sense to your design of the solid model, but I'm going to use the top plane. And once I have my sketch open, I will go to Tools, and I'm going to pull down Sketch Tools and Sketch Picture, and I'm going to bring in the heating element. And I'm going to size that heating element such that 1 inch on the picture is equal to 1 inch on the drawing screen of SolidWorks. So I'll start out simply by drawing a line 1 inch long, and that can be a construction line, by the way. We're only using it to scale, and I'll go ahead and dimension that to be 1 inch. And the next thing I'm going to do is drag the picture down so that I can get 1 inch that's shown on my screen here to be 1 inch on the ruler or the scale that's in the background. So to do that, I just simply double-clicked on the picture and opened up Sketch Picture again. And so I can drag one of these corners down to the point where the endpoints on my line match up with the inch marks on the picture. So all that's going on here is some scaling. Looks like we could go just a tad more down. Okay, so now I have 1 inch on my picture being equal to 1 inch on the heating element drawing. So the next thing I'm going to do is I'm going to draw some more construction lines just for the purpose of helping me get a better solid model. So I'm going to zoom in, and there's any number of ways to do this. This is just one approach to modeling this heating element. I'm going to try to get that angle in there, and that will be a construction line, and it will be, when I measured it in the lab, it was 0.44 inches. And while I'm here, I'll go ahead and add a vertical line, and I'll make sure it's a vertical by adding a constraint, vertical constraint to it. And I'll go ahead too and measure the angle between those two lines, and it's around 13 degrees. So I'll set that to 13, and again I'll make that vertical line a construction, and I'll zoom in on the opposite side here, and I'm again going to add a line that's 44/100ths long, and that will be also a construction. And I will include a vertical. I'll make sure it's vertical and it's construction, and I'm going to measure my 13-degree angle there. But picked up a degree. My picture is very pixelated, so it's hard to tell exactly where we're getting. If you had a higher resolution picture, you might have better luck in grabbing the correct points. So the next thing I'm going to do is I'm going to draw a spline that I'll start in the middle of those construction lines that we just drew, and I'm going to try to stay as close to the visual center of this element as I can. And that first section in there is relatively straight, and you may have noticed that yourselves when you were looking at this heating element. And so I'm going to proceed with making this spline, trying to stay as close as I can to what looks like the middle there. And that is the spline. Now you can turn on what are called the curvature combs, and these are helpful for telling you where your curvature might be off. And one place we can tell is right down here where this is supposed to be a straight line. Well, the center of curvature for the straight line is at infinity, and so the curvature there should actually be 0. So you can see these little gray arrows that are appearing along the spline, and those will help us control the curvature in certain portions of the spline. So I'm going to move that to the point where SolidWorks will allow me and make the curvature there 0. And then on the other side, I'm going to do the same thing. But it looks like my curvature there is relatively close to 0 as well. So I'll leave it, and if SolidWorks will allow me, I will go ahead and accept that spline. Okay. The next thing I want to do is I want to go along a surface that's normal to that line so that I can draw the features in true length. So in order to do that, I'm actually going to add a plane that's parallel to the right plane. Let me show you where my right plane is. It's right there. And I'm going to put a plane right through that point, that orange point that you see. And then I'm going to do some constructions that will help me identify a third plane. So what I'm getting ready to do here now is add a plane parallel to the right plane, and then I'm going to do some sketching on that plane that will help me define the plane I really want. Now, you don't have to go through all those machinations to get an angled plane, but I'm going to approach it that way so that you can see a different way to get this plane where you can view it normally and get the true dimensions of the features. So in order to do that, I'll turn back to the front view, or actually the top view, and I'm going to do a little bit of measuring here. So I'll go to Tools and Measure, and I'm going to actually measure from the origin to that point there. And I'm looking for 134.93 millimeters between the right plane and the plane I'm about to create. So 134.93 millimeters. And I'll close my sketch, and I'm going to use the right plane as my reference plane. And I'm going to select distance to be 134.93 millimeters. And that should pass right through that endpoint there. Now, what I'm going to do is go to this plane I just created. I'll hide the right plane now. And I'm going to go normal to this plane, and I'm going to drop a vertical down along this edge so that I'll have the endpoint here, the endpoint here, and then a point right below that on this plane that will enable me to define a plane that is on that surface. So I'll go normal to that plane, and let me make sure I'm not grabbing this spline, that I'm actually grabbing that point. So I'm going to open a sketch on plane number 1, and I'm going to drop a vertical line, zoom in just a bit, make sure I'm getting as close as I can to that endpoint. Drop a vertical line right there, straight down. And I'll make sure it's straight down by making sure that it's vertical, and we can make that a construction. Now I have enough information to add a plane that's running along the edge of the plane would be along this line. So I'm again going to close this sketch, and I'm going to add a reference dimension. And my first reference will be one endpoint. My second reference will be the endpoint of that angled line, and then I also want the length or some z dimension to help me give 3 points that make up the plane that I need. Now I'll hide this plane 1, and what I want to do is go in and draw the profile of this heating element so that I can sweep, use a swept boss to capture that geometry. So I'll go to the right plane. I want to be normal to that plane, and I'm going to add a rectangle, corner rectangle, and that cross section was square, so it was 0.44 by 0.44. And I will dimension that. And I will dimension this. And now we have a fully defined cross-section. The next thing I'm going to do is I'm now going to sweep that profile along this spline. And so to do that, I will use the swept boss command. And the swept boss command wants me to provide a profile, which will be that sketch that we just drew of the rectangle, and it wants me to provide a path, which will be the spline. And so I'm going to create the cross-section of that heating element, the square part, and the next thing I'll do now is a swept cut where I can add the hole in the top part of the heating element. That was the place where the copper tubing and ceramic insulation stuck out of the ends there. So I'll go to the right, to that plane, normal to that surface, and I want to find the center of that circle, so I'll do some construction lines here, find the midpoints with the cues that SolidWorks provides me. And again, these will be constructions. And the hole in that piece was 1/4 of an inch, so I'll add a circle so that we can cut sweep that 1/4 inch hole. And I'm going to go ahead too and measure from the center of that circle to the edges here. Okay, it looks like I might have grabbed that. Let me dimension the circle. 0 point. Okay, and so now it is fully defined, just needed to be dimensioned. And I will next cut that out along that same path using the spline we created earlier. So again, I will do swept cut as opposed to swept boss. Close the sketch. And I'll have to define my profile, which is the circle, and then I will also have to define the spline that we used, and that is right there. And so now that hole will be cut along the spline itself. And so you see how that heating element can be created using a swept boss and swept cut. Again, I think it's important to make sure that you get these planes correct in order that you get the true dimensions of the features. If we look at the top view of this heating element, we can see that we're getting the general shape of that geometry, that it's as accurate as it can be given the instrumentation and given the time that we had. So that's how you use Sketch Picture, and this video hopefully will help you out not only with modeling this heating element, but other geometries where Sketch Picture would prove useful to you.